we're finished chapter 1. However, there are some problems we haven't worked out yet in chapter 1. And let me check that real quick. Hold on. Yeah, so today we're going to start chapter 2, which is called More on Functions. We're going to pick up from where we left off. And that's why I gave you all the library of functions sheet last 2 weeks ago, so you start memorizing those. We'll need those for this because it's going to make it go much faster. And I'm not going to go back and review it all the time. But you guys are supposed to memorize those. So that I can't change that because we have a time limit to keep. The first section, we're going to get the graphs of functions. We're going to talk about whether increasing, decreasing, or constant. We're going to find things that are called maximum, minima. We're going to do word problems, applications. We're going to, given a function, we'll find the domains of them. And then we're going to look at what's called piecewise defined functions. That's one function with multiple parts. And then if time permits, then we're going to look at the algebra functions. When we say the algebra functions, the binary operators are add, subtract, multiply, and divide. We can do that with functions as well, not just numbers, but with functions. And then we're going to look at what's called the difference quotient. The difference quotient is another way of looking at the slope, which is also the beginning part of calculus. This is what calculus is pretty much based on, the difference quotient. All right, so that's chapter 2. But before we do that, I want to give you some more practice problems for chapter 1 in inequalities, because I don't think we did enough of those last time. So this is chapter 1, section 6, practice. Inequalities. Here's a question. Here's an example. Place the solution in interval notation and graph notation. What form is this in already? What form is this with inequalities in there? I gave you the two other ones, interval notation and graph. What's the third notation? Yeah, you're going to have to. Ideally, you should do that at home between classes, not during class. Set notation. This is in set notation. Because it has the inequality. First off, solve the inequality. What is that? How do we solve an inequality? What are we solving for? It's the only variable. Treat the inequality as an equal sign. So if this was your equation, and you're asked to solve for x, what would you do first? Very good. Always move the smaller x to the larger. Subtract 4x from both sides. 7 minus 4 is 3x. Now what? Get rid of the 6. Because we have to have all the x's on one side, everything else on the other side. So we have to subtract 6 from both sides. They're both negative, so the answer is going to be negative. 6 plus 3 is 9. Now what are you going to do? You're looking at the x, trying to get x by itself. Now we divide by 3. So it's only one negative, so the answer is negative. 9 divided by 3 is 3. It's usually easier to see and graph and everything if the x is on the other side, if the x is on the left-hand side. So we can flip this whole thing. There's the x. There's negative 3. The inequality is pointing to the negative 3. It has to keep, if you're going to move them, you have to flip everything. So this is what our in set notation. In interval notation or graph, it's usually always easier if you're going from one method to another, put it in graph form first. So when we have one number is at negative 3, is it an open or closed circle? It's closed because it's equality. What direction does the shaded region go? Yeah, since it's pointing to the right, it goes this way. And it goes all the way to positive infinity. So there's the graph. The interval notation, you take the lowest point, comma, the highest point. Infinity is always a parenthesis. Can we use a negative 3? Is it a bracket or a parenthesis? It's a bracket because it's a solid line. Another way you can see is in the set notation, it's got a horizontal line down here. So it's got a horizontal line down here. So that's another way you can tell. All right, let's look at another one. How about this one? 5 minus 2x is greater than negative 6x minus 4. What's that? Well, we have, okay, first off, yeah, I'm going to, there's a process. Are there any parentheses in the equation? No, you just have to get rid of the parentheses. Are there any fractions in the equation? No, because we have to get rid of those. So now we have x's on both sides. So which x do we move? Which one is larger? Always move the smaller to the larger. Which one? Which one's smaller, negative 2 or negative 6? It's negative 6 is smaller. Because if you look at our number line, -6 is there, -2. Because isn't -2 less than 0? So that means -6 is less than 2. So always move the smaller to the larger. So we have to move this one over there. Yeah, with negatives, it's opposite. So we have to add 6x to both sides. And the reason we do that is so we have a positive x when we finish. So 6 is positive, 2 is negative, so the bigger number is 6, so it's positive. 6 minus 2 is 4x. Let's see what would happen if we would have done the other direction. Let's say if we move the 2x over, six is bigger than 2, so it's negative. 6 minus 2 is 4. It's not wrong, but now you have to worry about that negative in front of it. So if you do your first step and you still have a negative in front of the x, move the other number. That's what we did here. So now what do we got to move? Move the 5. Subtract 5 from both sides. They're both negative, so the answer is going to be negative. So we add the numbers. 5 plus 4 is 9. Divide by 4. So the answer is -9/4. Let's move the 2 this time. I said, it's not wrong. It's just that you've added yourself 2 more steps. So if we move the 2 to both sides, so we add 2 to both sides. 6 is bigger than 2, 6 is negative. 6 minus 2 is 4. Add 4 to both sides. 9 is greater than -4. Whenever you change the sign of x, when it's by itself, you must change the direction of the inequality. So here, remember, always treat the numbers and the signs differently. So this is a negative in front of the x, so we have to change the sign. This one changes to -9, so that one changes. This changes to, and this number changes to a positive. So if you change the sign of x, you have to change the direction of the inequality. And this would also be the same thing if you want to divide by -4. Because you changed the sign of x. It used to be negative, now it's positive. Because now we divide by 4. If we flip, move the x there, it's pointing to the 9/4, so there. So you see the answers are going to be the same. It's just that you've added 2 more steps to it. What's that? Yes. That's going to be the most difficult part, because now you have to worry about, is it positive, is it negative? Do I have to flip the sign? Do I have to change the sign? And unless you're 100% sure, I've seen people just flip it for no reason because they said I had to do it somewhere. And that's not too mathematical of a logic. Let's do another one. If you want to come at the end of class, you want to take pictures of these first 2, you can down. But I'm going to send these out to everybody this afternoon. So it's your choice. Want to do another one like that? Oh, we haven't finished yet. Why have we not finished? Because we haven't put the answer in the other 2 notations. So this is your answer. Put it in the other 2 notations. In interval notation and graph. Okay, so as I said earlier, forget here, whenever you convert, because this is set notation, because it's got the inequalities, the notation. Whenever we go from one notation to another, it's usually easiest if we go through the graphing first. So if we graphed this, the only number we have is negative 9/4. Is it an open or closed circle? It's open because there's no line underneath it. It's not equal to. What direction does it go? Well, again, whenever your x is on the left-hand side, follow that arrow. It's pointing to the right, so we shade to the right. And it goes to positive infinity. But that only works when x is on the left-hand side. That's why people like to switch it over. It makes it much easier that way. Okay, so now once we did the graph, the lowest point and the highest point, so we have negative 9/4, comma, infinity, parenthesis or bracket, parenthesis, and it's always parenthesis. So there you have it. So that's what I'm saying. It's always easiest to convert from one notation to graphic and then to the other one. Given. Given this information, put it in set notation and graphic notation. So the graph, let's do the graph first. We have -3, we have 9. Is it an open or closed circle on -3? It's closed because it's a bracket. And it's open on 9. And it's between there. These are all my x's. So it goes from -3 to x to 9. At -3, is it included? So -3 is less than or equal to x. And this is strictly less than. Okay, put those in the other two notations. Put that one in the other two notations. I went in set notation and interval. Okay, what's the difference between set and interval notation? What distinguishes them apart? What does set notation look like? What symbols? Yeah, and that's right. And interval notation deals with parentheses and brackets. So we know that much. That is important because I've had students mix those up and the computer always counts them wrong. So let's put it into set notation. Remember, the shaded region is what your x is. On the left side, x is to the left of 4, so x is less than, and is it equal to or not? So it's less than equal to 4 on this side, and x is greater than, is it equal to? No, greater than 9. Easiest way also, remember, as I just said, if your x is on the left-hand side, like this one, here's 4, and here's my x's, the arrow points the direction it's shaded. So here's my x, it's on the left-hand side, there's my 9, it's shaded to the right. What goes between there? It's only one thing goes between there. What is it? What's that? Or what? Yes, it is or. Yes, because this it says x is less than equal to 4 or x is greater than 9. How would you do interval notation? Interval notation, you have to have a beginning and an end in each interval. So on the left one, we start at -infinity, comma, we go to 4. Now in this interval, infinity is always parenthesis, and since 4 is a solid dot, it's a bracket. And on the other set, we start at 9, comma, that means we go to positive infinity. And they're both parentheses. What's in the middle? Union, the U, right? So far, so good? Put it in the other two notation symbols. What's the first thing you got to do? Remember, this type of problem, because we have three sections, this is called a tripartite. We have three parts. We only focus on the part that has the x. That tells us what we have to do. We try to get the x by itself. What do you have to get rid of first? Get rid of the 2. We subtract 2 from everybody because it has to stay equal. -3, -2, they're both negative. So the answer is negative. So we add them. 3 plus 2 is 5. 4x. 9 minus 2 is 7. Then what? Then what? What's that? Get x by itself. How do we do that? Exactly. Divide by 4. Again, the only thing you should worry about is that right there. And that tells you get rid of the 2 first and then divide by 4. The rest of it's just the icing on the cake on the sides. Whatever you do to the middle, you do to the other sides. And there's our answer. In what notation? Set notation. Very good. So how do we put it into interval notation? What do I have to do first? If going from set to interval, graph it first, because this is going to help us. In this, our lowest number is -5/4. Our biggest number is 7/4. X is between there, so that's shaded. These are all my x's. Open or close circle on the left? Close, because it's equal. And then the other side is open. So this tells us what we have already. This puts it in interval notation for us. We put the smallest number in our range, our domain, and the largest number. Parenthesis or bracket on the left side. It's bracket. It's bracket because there's a solid line down there and there's a solid line right there. Since that's a circle made up of, that's that. Let's do one more. Yeah, just 3. Yeah. Let's put all this stuff together we've been talking about for the last couple of weeks. Remember, whenever you solve inequalities, it's the same thing as if they're equal signs, right? What did I say our rule was whenever you see equal signs in fractions? Get rid of the fractions, right? So do the same thing here. Get rid of the fractions. First step, find the LCD. What is the least common denominator of these three denominators? 12? 5 doesn't fit in 12. Which one? Louder. 20, yes. Remember, think about it. Is if we have 5, 4, and 2. 5 is 5, 10, 15, 20, 25. This is 4, 8, 12, 16, 20, 24. And 2, 4, 6. So 20 is the smallest number they all fit into. So the LCD is 20. What do we do with the LCD? Multiply each term by the LCD. How many terms do we have in this equation? 1, 2, 3, 4. We have 4 terms. So it put 20 in front of each of those. So it's 20 times 3 over 5. 20 times 1 over 4. 20 times 3x over 2. And 20 times 3. So we found the LCD. We multiplied each term. Third step. Whenever you multiply fractions, never multiply first. Always reduce first and then multiply. So reduce first. 5 goes into 20 how many times? 4. This is 20. 4 goes into 20. 2 goes into 20. And there's nothing down there. So what we have now looks like this. It looks a lot easier. So we found the LCD, multiplied it, reduced. So we got these two are identical to each other. I just got rid of the fractions. Now you multiply to get rid of the parentheses. 4 times 3 is 12. That's 5 times 1 is 5. Negative times positive is negative. 10 times 3 is 30. Less than. 20 times 3 is 60. Last step is we solve. We're solving for x. So we subtract 5 first from all 3 sides. 12 minus 5 is 7. Those cancel. Negative 30x. 60 minus 5 is 55. Now we have to do what? Do not say divide yet, because there's a negative in front of there. change everything across the board. This goes from +7 to -7. This one changes from pointing left to pointing right. This one changes from negative to positive. This one changes direction, and this one changes from positive to negative. Because again, this is one of the reasons why I try to stress for you guys to keep away from dividing by negatives. If you divide by negative, 99% of the time you'll forget to change the inequality signs. But when you change the sign, everything changes. You're changing it from positive to negative. You're changing it from less than to greater than. So everything changes when you change the sign of X. And then last step is we divide by 30. Negative. They both have a 5 in common. 5 goes into 55 11 times over 6. Are we done? We're not. No, it's not in the right format yet. Because remember, we have to read left to right. It goes from smallest to largest. This is backwards. We have to take this entire equation and flip it. This number comes over here. X stays in the middle, and this number goes to the other side. The arrow still points to 11, negative 11 over 6. The arrow still points to the X. So it's like taking your paper and just flipping it over, and that's exactly what I did. Now it's correct notation. Now we can go ahead and graph it and put it into the other notation. Because this is set notation. What's the graph going to look like? The small number is here. The big number is here. And X is in the middle. Since they're both strictly less than, they're both circles. So this is my X. So that means I go from 11 over 6, comma, to negative 7 over 30. And they're both parentheses because they're open. And that's my conversion. The confusing part about this is remembering what the notations stand for and how to find them. This is set notation, this is interval, and this is graph. Other than that, it's low end, low end, low end, high end, high end, high end. It's either parentheses, brackets, open circles, or closed circles. And those are the examples I was wanting to talk to you about. Any more questions? Yeah, this came from a long way from originally started. Let's do a couple of problems an hour ago. Because I mean, maybe a little bit too late to even start chapter 2 yet. Because originally we're going to do chapter 2, which is the new chapter we're going to start. We're going to look at increasing, decreasing, constant, maximum, minima. We're going to do some word problems, finding domain, and piecewise. Actually, we could do these two this morning. So let's begin chapter 2. Chapter 2, section 1. Graphs of functions. What we're going to cover today are intervals where the function is increasing, decreasing, or constant. And then we're going to try to find what's called a maxima or minima. Let's define these words first. How would you define when a function is increasing? What makes it increasing? In words, not pictures. Going up. But how do you describe that? How do you prove it mathematically? But you're right. I mean, a graph that is going up. That's the most vague you could have said it. Going up where? How? Is that an increasing graph? That's going up? So what's actually happening here? What is the slope of an increasing graph? Is it positive or negative? Yeah. So we know the slope is positive. It's greater than 0, which means what? Because remember, the equation of a slope is y2 minus y1, x2 minus x1. For this thing to be positive, that means y2 has to be bigger than y1, and x2 has to be bigger than x1. Because if it wasn't, then this would be negative, or that would be negative. So what this is saying is we have 0.1, which is made up of x1, y1, is going to be less than or lower than 0.2, which is x2, y2. So that's exactly how we're going to have to look at things. If we have 2 points on our graph, it's increasing if this is true. It's increasing as if the first point is lower than the second point. It's increasing if this is true. What number in a fraction, which number, the top or the bottom, can be negative? Can the bottom ever be negative? No, because x always moves on forever. So the way we would look at this thing, increasing function, as x goes to infinity, positive infinity, what this means is x1 is less than x2, is less than x3, is less than x4, and so on and so forth. As x goes to infinity, y1 is less than y2, is less than y3, is less than y4. Basically, this is how we say it in mathematics. The y value of I is going to be less than the y value of I plus 1. So if I equals 1, then y sub 1 is less than y sub 2. If I equals 7, then y sub 7 is less than y sub 8. So that's what increasing is. So the way you look at to see if 2 points are increasing is you pick an x value, find the y value, then pick the next y value over and see if that y value is higher or lower. If it's higher, it's increasing. If it's lower, it's decreasing. So that just went and defined our decreasing, a decreasing function. A graph that is going down. And same logic and reasoning here. We know a function is decreasing is if we have an x1 that is less than x2 and y2 is less than y1, then it's decreasing. Or you can say that y1 is greater than y2. The first y is higher than the second y. Then it's a decreasing function. Because the slope here is negative. It's going down. So let's see how this works. Let me put an equation up there and a certain domain, a certain interval, and you tell me whether it's increasing or decreasing a function. On that interval, is the function increasing or decreasing? Again, you can't just jump. It's a math course. It's not a history course or English course. You can't say, I think it's this. You have to work it out. I just showed you how to work it out. I explained to you how to work it out. This is x1 and this is x2. Plug them in there and see what the y values equal. If x equals 0, if x equals 2. Zero cubed, 2 times 0 squared minus 0 plus 1. That's 0, 0, 0, so it's 1. So x1 is 0, y1 is 1. Negative x is 2. 2 times 2 squared minus 2 plus 1. So I plug in x's in this equation, 1 for each one of these. What is 2 cubed? 2 times 2 times 2 is negative 8. 2 times 2 is 4 times 2 is 8. 2 squared is 2 times 2 is 4. Negative 8. 2 times 4 is 8. Negative 8, positive 8 cancel, so I have negative 2 plus 1, negative 1. So y2 is equal to negative 1. So is this an increasing or decreasing function? Why? No. You have to compare. Remember, in order to tell me if it's increasing, decreasing, when x1 is less than x2, it's increasing if y1 is less than y2. It's decreasing if y1 is greater than y2. Because x is always increasing. x1 was 0, x2 is 2. So here are our y values. Are they increasing or decreasing? Is this one bigger than this one? Or is this one less than this one? It's bigger. Positive is always bigger than negative. Since y1 is bigger than this one, then we have a decreasing function. Our function is decreasing. That's how you do it. You can't just say it's positive, negative. You have to show me the numbers. This is the function y equals negative x cubed plus 2x squared minus x plus 1 is decreasing on the interval 0, 2. It doesn't mean it's always decreasing. It just, in our small domain, it's decreasing. Because this function would actually look like this. Let's call that A. Let's call that B. Tell me where this function is increasing, where it's decreasing. Where is this? Where is it increasing? Where is it decreasing? What's that? I want an interval. But actually, in any one of those three methods that we talked about, set or interval notation, but it's usually easiest if you give me an interval notation. So again, let me show you how to do this one. You read left to right. Going from negative infinity to A, is it going up or down? The graph is going up. The graph is going down. This is decreasing. So it's going from negative infinity to A, it's decreasing. From A to B, what is it doing? It's increasing. So from A to B, it's increasing. And from B to positive infinity, what is it doing? It's decreasing. So from B to positive infinity, or we could do it like this. So that's how you want the answer to be done. Look at the picture. If it's going down, look at it as you're reading history at time. Is it going downhill or uphill? This is going downhill to there. At this point, then it's going up to this point. Why do I have only parentheses, no brackets here? Because at A, it's neither going up nor down. It's actually got a flat. So if you look at it in slope-wise, is this slope over here positive or negative? This slope is negative. How about this one? How about this one? What happens here? What's the slope of these 2 points? Look at the line. What's the slope of a horizontal line? 0. Because at that point, at A, it's neither going up or down, it's 0. That's why we always put parentheses. These actually have names. This is the lowest point, right, of this curve part. The Latin word for the lowest point is called minima. You've heard minimum, the lowest number. That's called the minima. What's the highest number called? Maxima. So you can find the maximum minima by finding where the slope is 0. If you look at the curve, see where it bends, where it's neither going up or down. That's what those are. Easy? The answer should be yes. Okay, again, we're now looking at a different way of looking at things. But again, we have to learn how to look at the graphs from left to right. And if you put your pen there, if I'm going this way, am I going up or am I going down? I'm going to the bottom of the page. It's down. So this one's going to the top of the page. There's no way down. And that's what you have to look at it. And we'll pick up from here next time. Yeah, because I want you all to concentrate more on chapter 1. And I'm glad we did the practice problems for chapter 1.